So now we will look at composition of transformations. Composition of transformations are when two or more transformations are combined to form a new transformation. The result is called a composition. In a composition, the first transformation produces an image upon which the second transformation is then performed. The symbol for a composition of transformations is an open circle. You will use that along with the shorthand notation that we worked on prior to the quiz. The thing that you have to be careful about is the transformations are done in reverse. So, for instance, if you had this, the first transformation that you would do would actually be the second one that's listed. So that would be a rotation of 180 degrees. And then after you rotated that pre-image 180 degrees, you would take that new image and then you would translate it 4 to the right and down 5. So you have to be careful because it's done in reverse order. So for example 1, we are going to perform the composition of r sub x equals -1 with r sub x equals 4 on the quadrilateral in the graph below. Then once we get it graphed, we will look at the graph and the coordinates and determine if a single transformation can get you from the original pre-image to the final image. So the first thing you want to do is pay attention to the order. Remember that when it's written with this composition rule, the second transformation is what you do first. So a little r means a reflection, and then the subscript is what you are reflecting it over. So we are reflecting over x equals -4. So we're going to take A, B, C, D and reflect it over x equals -4. So I'm going to go ahead and do that. One of the things that sometimes, sorry, not -4, that's just regular 4. One of the things that sometimes students mess up is where to draw 4. So go to where x equals 4 and then draw a vertical line. That is the line that we are going to reflect over. There is no coordinate notation for a reflection over the line x equals 4. You must count. So you're going to count from each point to the line and then count the same distance on the other side of the line. So A is 2 to the right of the line. So if we count 2 to the left, that would put A prime at 2, 3. So it started at 6, 3, and now it's at 2, 3. For B, it starts at 8, 3. And if we count from that point to that vertical line, that's 4 units. So now we're going to count 4 units to the left, and that puts B prime at 0, 3. C is 8, -2. It is 4 units away from x equals 4, so we're going to go 4 units away on the other side, and that puts C at 0, -2. And finally, D is sitting at 6, -2. It is 2 units away from x equals 4, so if we count 2 units on the other side, that puts D prime at 2, -2. So just a couple of reminders that when you reflect, the orientation becomes the opposite. And what that means is if you read from any point to the next point, so I'm going to use A to B, that on the pre-image is in a clockwise direction, but on the image is in a counterclockwise direction. So the orientation is now opposite. Okay, so what we're going to do now is we're going to take our new image and we are going to perform the second transformation, which is a reflection over the line x equals -4. Let me change that color, it's pretty hard to read. And that says -1. Okay, so I'm going to go to where x is -1, just right here, and I'm going to draw a vertical line through x equals -1. And then I'm going to do the same thing that I just did. I'm going to take a prime, count to x equals -1. It is 3 units to the right, so I'm going to go 3 units on the left side. And that, when you do a double transformation, you would say a double prime. And that puts it at -4, 3. B prime is 1 unit to the right, so we're going to go 1 unit to the left. And that puts B double prime at -2, 3. C prime is 1 unit to the right, we go 1 unit to the left. That puts C double prime at -2, -2. And finally, D prime is 3 away to the right, so we'll go 3 to the left of x equals -1, and that puts D double prime at -4, -2. Okay, if we compare those points to the A prime points, from A prime to B prime, we went in a counterclockwise direction. And then now if we go from A prime, double prime to B double prime, we're going back in a clockwise direction. So by reflecting, we change the orientation to the opposite. We reflect it again, which flips it back to the original position. So what I want you to think about is ignore the middle ground. I'm going to erase it so that you guys can see it. How could you get from A, B, C, D directly to A double prime, B double prime, C double prime, D double prime? The orientation is the same, so that leaves out a reflection. I have had some students say, oh, can't you just flip it over x equals 2? And although the shapes would match up, the points would not, because A would fall on top of B double prime, which doesn't make sense. That's why labeling is important, and that's why paying attention to the orientation is important. If from A, B to A double prime, B double prime has the same orientation, then we know it's not a reflection. That leaves us with either a translation, which is a slide, or a rotation. So you have to think to yourself, does it slide or does it turn? If you look at the points have not turned at all. So that leaves us with a slide or a translation. Specifically, a translation to the left. And then to get even more specific, you would need to count from A to A double prime or B to B double prime. But if you count, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So translate 10 to the left. And to write our rule in coordinate notation, remember coordinate notation, coordinate means point, so it starts with x, y, and then maps or yields. What happened to the x coordinates? Well, they went to the left 10, and when you go to the left 10, you subtract 10 from x. If you look at all your x coordinates that you started with, 6 and 8, and you compare them to where you ended with, 6 became -4 and 8 became -2, your x values decreased by 10. So x minus 10 is what they did numerically or visually. You went left 10. What happened to the y coordinates? Nothing. They're 3. or -2 throughout the whole entire problem. So the y stayed the same, so we just write y. You do not need, nor should you, write y plus 0. Okay, let's try another one of these. For this one, again, remember, watch the order. What we're going to do first is what's listed second. So that is a reflection over the y-axis. Remember that the y-axis is the vertical axis, so right here. You have two options for flipping over the y-axis. You can count, like we did in example 1, or you can use the rule. Either are completely fine. So I'm going to go ahead and identify the coordinates of A, B, and C. A is -1, -6. B is -3, -2. And finally, C is -8, -7. So if you want to count, you would count from A to the y-axis, which is 1, and go on the other side 1 unit, and that would be A prime. Looking at the coordinates, that is +1, -6. And then you could do the same thing for B and the same thing for C. Count to the y-axis and then count on the other side. If you know your rule for reflecting over the y-axis, when you do that, the x becomes the opposite and the y stays the same. So if you don't want to use counting, you can use the rule. So you take point B, make x the opposite, which is 3, keep y the same, which is -2. To get C prime, look at C. Make x the opposite, which is 8, keep y the same, which is 7. But again, you will get the exact same points if you count to that y-axis and then do the same thing on the other side. So C is 7 to, actually it's 8 to the left, go 8 to the right. And put right there at 8, -7. Okay. Now we're going to take that triangle and we are going to do a reflection over the x-axis. And again, if you prefer to count each of your new points to the x-axis, you can, or you can use the rule. The rule says that x stays the same, but y becomes the opposite. So if you look at A prime, let x stay the same, but let y become the opposite. So that would be 1, 6. If you're counting, A prime is 6 below. So if you get 6, if you count 6 above, that puts A double prime at 1, 6. Using the rule, look at B. X stays the same, so it stays 3. The y becomes the opposite, so it changes to 2. If you want to count, B prime is 2 below the x-axis, count 2 above, that puts you at 3, 2 for B double prime. And finally, from C to C double prime, take that x, keep it the same, take the y, and make it the opposite. So from C double prime, that should be 8, 7, or if you count, it's 7 below, go 7 above. That puts you at +8, 7 for C double prime. I'm going to ask you to do the same thing that you did in the last one. Ignore that middle transformation. How can we go directly from ABC to that final image of A double prime, B double prime, C double prime? Visually, this may be a little bit more difficult. Maybe you think it's a reflection. If you think it's a reflection, look at the orientation. From A to B is a counterclockwise direction. From A double prime to B double prime, it's also a counterclockwise direction. So it has direct orientation. And if it's direct orientation, then it is not a reflection. It must be a translation or a rotation. But the figure clearly changed the way it's facing. So if it's not a reflection, then it must be a rotation. It changed 2 quadrants. When it changes 2 quadrants, that is a rotation of 180 degrees. You can also look at the coordinates from A to A double prime, or B to B double prime, or C to C double prime. What happened if it went from -1 to +1, or -3 to +3, or -8 to +8? The x coordinate became the opposite. And then for your y coordinates, they went -6 to +6, -2 to +2, -7 to +7. The y coordinate also became the opposite. So that is your rule for rotating 180 degrees. So when you write your coordinate notation, x, y maps opposite x, opposite y. All right, so for example 3, we're going to look and see if the order matters. I want you to think back to example 2 that we just did. We reflected over the y-axis and then we reflected over the x-axis, and we decided that that was equivalent to a rotation of 180 degrees. What if we switched the order? If we went over the x-axis first and then the y-axis, would we end in the same position? And the answer would be yes, because when you reflect over the y-axis, the x-coordinate changes. And when you reflect over the x-axis, the y-coordinate changes. So since your transformations impact different coordinates, it doesn't matter. So for example 3, we're going to do a reflection over the y-axis and a translation to the left 2 and down or up 0. And we're going to see if it matters. So for the graph on the left, we are going to look at this rule right here. Remember that when you're doing that, do the second transformation first. So we are going to translate. Remember, T is for translate. The first number tells you if you go left or right. Since it's -2, that's left 2. And the second number tells you if you go up or down. Because it's 0, we don't go up or down. You don't need to write anything. You don't need to say up 0 or down 0. Just don't even say it. Right? After we do that, we're going to take that new image and then we are going to reflect over the y-axis. All right, so I'm going to kind of do them sort of at the same time. So I'm going to take A and I'm going to move it to the left 2. I would put A prime here. And then I'm going to take that and I'm going to reflect it over the y-axis. I'm going to count just because I don't have all my coordinates in front of me like I did example 1 and example 2. So if we count over the y-axis, it is 4 away on the right, so we'll go 4 away on the left, and here will be A double prime. All right, I'm going to do the same thing with B. Count 2 to the left. There's B prime right on top of where A was. And then we're going to count to the y-axis, which is 6, and count 6 on the other side. B double prime. For C, count 2 to the left. It falls on top of D. And then it is 6 to the left, or to the right. We're going to go 6 to the left. Make sure I get it right underneath it. There's C double prime. And then finally D, move it 2 to the left. and then flip it over that y-axis. And it's 4 away, so we'll go right here. Okay. So there is your image after it has been translated left and then reflected over the y-axis. We're going to do the same thing for the next one, but we're going to do it in reverse order. This time, we're going to reflect over the y-axis. So forgot to write over. And then we're going to translate left 2. All right, so I'm going to count. When I reflect A over the y-axis, let me go ahead and draw that so you guys can see that vertical axis. A is 6 to the right. I'm going to go 6 to the left, which is going to put it right here at -6, 3. And then I'm going to take that and I'm going to move it 2 to the left. So A double prime is at -8, 3. For B, it is 8 to the right. I'm going to go 8 to the left, what it actually puts it right on top of A double prime, but then I'm going to move it to the left. So that puts it at -10, 3. For C, it's 8 to the left, or 8 to the right, so I'm going to go 8 to the left, which puts it right here at -8, -2, and then I'm going to move it 2 to the right, 2 to the left. And then finally, D is 6 units to the right. I'm going to go 6 to the left. And then I'm going to move it 2 to the left from there. So it falls right on top of C prime. Okay, so here is where I end up for the second one. So does the order matter? Did those two rectangles fall in the exact same position when we were done? No, they did not. So then that means the order mattered. And so what we're going to do is we're going to learn how to write the rule. Even though for this one, there may not be a single translation, there may or may not. A single transformation like the first two that we did, we're going to learn how to write a single rule in coordinate notation. So look at the next slide. Okay, so we said the transformations are not the same. So now we're going to write the rule in coordinate notation for the first graph and then the second graph. So on the first graph, we shifted left 2 first. When you shift left 2, that makes all your x coordinates decrease by 2, but all your y coordinates stay the same. Then we reflected over the y-axis, and when you reflect over the y-axis, the x coordinate becomes the opposite. Well, the problem with this is we don't just have x now, we have x minus 2. So this whole x minus 2 is acting like x. That needs to become the opposite, so I need to put it into parentheses. I am totally fine with you leaving it like this. You could distribute the negative to the x and the -2 and write it as -x plus 2 comma y if you want. The y stays y because if you look at the y coordinates, they stayed completely the same. They never changed. For the second graph, we reflected it over the y-axis first. So first, our x coordinate became the opposite and our y coordinate stayed the same. Then we moved it left 2, which means you're subtracting 2 from the new x. So if you look at them, the rules are slightly different. Not significantly different, but they are a little bit different. And that's why that order matters, because when you reflect over the y-axis, the x coordinate changes. And when you reflect over, when you translate left 2, the x coordinate also changes. So because both transformations impact the x coordinate, then order is going to matter. Whereas in that example 2, one impacted x and one impacted y, so the order did not matter. For the last example, you have a graph of a pre-image and an image, and you are writing what two transformations could move from figure A to figure B. Now, this can definitely be done in more than two transformations, but we're just going to focus on the two transformations for this particular one. Sometimes this is trial by error. It kind of depends on how your brain processes the pictures and how visual you are. So kind of play with it, maybe identify a couple points and try actually doing the different transformations. So there are two ways you can handle it. You can work on trying to get it in the right location first, or you can work on trying to make the orientation look the same, which is kind of what I prefer to do. So what I would do first is I would take figure A and I would flip it over the y-axis so that it pretty much looks like B, but it's got to move to get to B. So the first thing I would do is reflect over the y-axis. That's me personally. That's not what you have to do first. But now that it is in that same kind of position, now all we got to do is translate it. We got to figure out how much you're going to translate it. Make sure that you pick a point. So I'm going to pick this top corner point right here. Go to the same point on the image. So that would be down 1, 2, 3, 4, 5. So translate down 5. So to write the rule in coordinate notation, start with your basic coordinates. If you reflect over the y-axis, the x-coordinate becomes the opposite and the y stays the same. And then if you go down 5, your y-coordinate is going to lose 5. So that would be the rule. If I'm going to do the composition notation, remember that you write it in the reverse order. So first we reflect it over the y-axis and then we translated it down. So we're going to write the translation down first. So t, then the first number tells you how much you moved left or right. We did not. The second number tells you how much you moved down. We moved down 5, so that's negative. Then your composition. And then your reflection, little r, over the y-axis. For this particular one, because a reflection over the y-axis impacts the x-coordinate and translation impacts the y-coordinate, the order would not matter in which you did these transformations. You could move it down 5 first and then flip it over that y-axis. And again, there's ways to do this with rotations and reflections and translations, but it would take more than two transformations to get there.